hello again and welcome. Again, my name is Jana and I'm studying design in my master's at the Niederrhein University of Applied Science in Mönchengladbach, Germany. And I'm also working at the university and contributing to some projects. And if you're interested in, it will be presented tomorrow by Ellen Bent. So if you're interested in further information about recycling, maybe it might be interesting. So I'm very grateful to be here today. This is also new for me. And yeah, tell you something about my bachelor thesis that I finished last year. And in this, I developed a recyclable rain jacket. So this presentation deals with design in the context of recycling. So the presentation is divided into 9 parts. And first I will introduce a little bit and then explain the purpose and the methodology of my work. Then I will have a look at limitations and possibilities of polyester recycling. And afterwards, I will determine the criteria for the jacket in the following section. Next, I will give you an overview of all the chosen materials, which is followed by some material tests on an ultrasonic welding machine. And finally, I'll show you some important design elements. So first, a little introduction. So as we all know, fast fashion is causing many problems. So it is also the case with recycling, because the low quality of the product itself and the material and the fiber lead to a less economic recycling. So in most cases, worn-out textiles can only be downcycled. In addition to that, the increasing amount of synthetic fibers is causing problems because the most common technologies are suitable for other materials like cotton or wool. And another upcoming problem is that in order to meet different functions in a garment, it consists of many, many components, and these components aren't easy to separate. So therefore, the current recycling system is about to change because it's no longer workable. So as I mentioned before, garments consist of many, many components in order to meet different functions. So to me, the question arises if recyclability and function represent a contradiction, especially in the case for functional garments, of course. So the purpose of my work was, on one hand, to reduce the amount of different materials. So I only use components labeled with 100% polyester. But in addition to that, the function of the rain jacket should not be impaired. So the goal was to develop a prototype which meets these both criteria. So the methodology I used to achieve this was, in the first step, to do a big research on recycling technologies and all the possibilities and limitations, which also included the process of collecting and sorting, for example. And then, upon this, develop special criteria to make the garment recyclable. So basically, I try to incorporate this knowledge into my design. And yeah, as you can see in the design process, maybe an interesting point about this is that the materials were chosen at first stage because they crucially influence the rest of the design process, for example, the design elements or the pattern development. And not to be forgotten, the functional aspect played an important role at all stages of the design process. But to really close the loop, it was really important to keep everything in mind at the same time. So referring to my title, referring to the title of my thesis, Design for Cyclability, let's have a look at the recycling options for polyester and the possibilities to use it for fibers again, because this is what a closed loop really means. So of course, collection and sorting process, as I said, can also have crucial impact, but let's have a look have a closer look at the recycling of the material itself. So mainly there are two ways, the chemical and the mechanical process. First about the mechanical process. It's made by crushing, melting, and purifying the waste. And this is possible because of the thermoplastic properties of polyester. So one benefit of this mechanical process is that it's technically proven and feasible and much more easier than the chemical one. And in this process, normally the color remains in the melt. So there's the option to use the color again, which often leads to black and gray tones. In this process, some impurities can be removed, but it's not easy to mix polyester with other plastics because of the different mechanical properties. For example, other plastics can be nylon or polyurethane or something else. So another important point is that mechanical recycling always comes with a loss of quality. So it's necessary to add new polyester too in the process. In addition to that, it's very important to have a very high purity of the waste because these impurities can interfere in the spinning process later. So if you want to make fibers out of polyester waste, it's very important that's a very pure waste. So normally plastic bottles are used as a feedstock to do this because they have much less impurities than textiles. In the chemical recycling, polyester is depolymerized with chemical agents. And this leads then to chemical building blocks, which can be used to produce polyester again. And the most important benefit in this process is that all impurities and also the colors can be removed. So you can produce a very high quality polyester, even if the waste was highly contaminated. And this is why the chemical recycling is also called closed loop recycling, because it comes without a loss of quality and you can produce the same quality as new polyester again. The waste should at least consist out of 80% of polyester to make the process profitable. But nevertheless, this process is much more complex and energy intensive, which might be a reason for the higher prices in the end. So in my conclusion, the mechanical recycling should always be preferred if the purity of the waste is high enough. So as a result, the content of polyester in the final garment should be as high as possible, as I already said. And this brings me to the next topic, the criteria for recyclability. So the most important criteria in order to do the recycling, to make the recycling possible, is the monomateriality, as I mentioned before. I've listed here some impurities or possible components which should be avoided as much as possible. This can be other fibers, or elastan is also a problem in the process, but also coatings and prints, adhesives, pigments, or different colors, or completely different materials like metal or something else. So if this monomateriality is not possible, the second step is to make these components detachable. For example, with a special cut design that makes components easy to separate. So the next step was to find appropriate materials, which you can see here. So let's go through the materials and I'll tell you something about it. First, we have a look at the fabric. The fabric is provided by Sympatex, and it's a 2-layer laminate with a membrane. And this fabric is multifunctional, which means it's breathable, but still water and wind repellent. So it significantly contributes to the function of the jacket. So Sympatex has labeled this fabric with 100% polyester, but to connect these both layers, the membrane and the fabric, it is used polyurethane to connect these layers in a process that is called dot lamination. So the tape you can see above is also provided by Sympatex, and it's necessary to seal the seams so that no water can pass through. So this also contributes to the function. This tape also has an amount of polyurethane, but yeah, we don't know how much. So this polyurethane is really a problem for the recycling process because it's a different type of plastic with different properties than polyester, and it can interfere with the recycling process, especially in the mechanical, but also in the spinning process later. So the exact proportion of polyurethane in the fabric and in the tape are not disclosed by Sympatex. So also the amount in a final garment cannot be determined. But nevertheless, small amounts of polyurethane can be tolerated in the mechanical recycling, but there's no clear reference on the exact proportion. So this is the reason why especially the tape should be used as less as possible in the jacket. So if you want to get to know about this aspect in detail, you can see it in my paper, in which I made kind of a hypothetical calculation. In addition to that, Sympatex mentions that it's possible to dissolve this polyurethane chemically with an extra step in the mechanical process. So let's go to the zipper. The zipper is called Natulon. It's from YKK, and it almost consists of 100% of polyester, except for the top and the bottom stops of the zipper. So for the recycling, this means not the whole zipper has to be separated from the garment, only these small top and bottom stops, which makes it much more easier. And due to the monomateriality, the zipper is not water repellent. So this has to be considered in the further development. For the inner lining, I chose 3 different fabrics, which are all labeled with 100%. So there's no problem in sewing them together. So this also goes with the trims. They are also labeled with 100%. And on the left, you can see kind of a special mesh tape I used to enforce the shield of the hood. And this material is very stable and can be shaped permanently. And it's normally used to strengthen hats or skirts, for example. And yeah, as I said, I used it for the shield. And the benefit with that is that the whole jacket manages without an additional adhesive interlining. So last but not least, we have the cords and the trims, which are labeled with 100% nylon. So they come up without elastane or metal or something else. But for this reason, these components have to be easily detachable so that they can be recycled separately in the nylon material cycle. So as I mentioned before, it was crucially important to use as less as polyurethane as possible. So this was the reason why I tested the material on the ultrasonic welding machine, because with this joining technology, the seam tape could have been avoided. And so the associated use of polyurethane could have been avoided. Yeah, but as you can see, it didn't work well with this material. So I had to go the traditional way and use the seam tape to guarantee the function. So in the following, I'll show you some examples of the jacket, some elements that are maybe important for design for cyclability. Yeah, and as I said before, one important point was the minimum use of seam tape. And yeah, on one hand, I'd achieved this by using the tape only for the most important seams. So the hem and the side seams, for example, were not taped. As you can see in the right picture, there's a kind of an overview of the tape use. But on one hand, in addition to that, I chose a seam-reduced design at all. So the jacket has, yeah, kind of a minimalistic look because of the less seams. So another way to avoid tape is to cover some seams at all with a seam that is already taped. So this is the case, for example, with the pocket construction. because all seams of the pocket are covered by the panel, so there is no additional seam needed that has to be taped at all. Furthermore, it was really important to do flat curves in a construction, for example, in the armhole. So here you can see the removable cords on the left picture, and yeah, there you can see both ends of the cord have to be open and look out of the hem. So because the cord can't be sewn to the jacket at any place to make it easy separable. On the right picture, you can see the zipper, and the zipper is covered at the top, and it requires kind of a panel, as it has no waterproof coating to maintain the monomateriality. This panel has an additional piping, as you can see, so that the water coming from the side can run down. So it also has some functional aspects. So now you can see the hood of the jacket. The hood has, as I said, a visor that can give extra protection from rain, but it also can be rolled up into the collar. And yeah, on the right picture, you can see the drawstring a little bit, which is also at the inside of the hood. So this was also made to reduce the amount of tape seamed at all. Yeah, and the picture in the middle also shows the cord with a special sliding knot. And through this knot, the cord can be adjusted, and there's no need for an additional cord stopper. So here we have a reduction of components as well. So at the end of the presentation, let me summarize a little bit. So first, the function was, the function, which means the protection from rain, was provided by the choice of material and the design elements. But a final statement about the recyclability can only be made to a limited extent due to lack of information about the proportion of polyurethane in the entire garment. But at least it could be reduced to a minimum. So in addition to that, the material test shows that this laminate is still unsuitable for the technique of ultrasonic welding, but nevertheless it can bring a potential, because it brings a big potential in terms of monomateriality. So another important point, another interesting point was that the design strategy I used here can lead to innovative ideas and the use of unconventional materials. And yeah, in my opinion, in the future, it will be more important than ever, not only for designers, but for all stakeholders in the textile and fashion economy, to find solutions for complex problems like this. So I think the sharing and exchanging of knowledge between these stages will have an important role here. So here you can see an overview of my references. And then if you have any questions, don't hesitate to ask me. And thank you very much for your attention.